Hello, good morning, everyone. Let's continue in lecture 2. So last class, at the end, we talked about um, the genetics, right, of blood types, specifically the genetics related to the ABO blood group. We made this chart, but I said we're gonna add more columns to it, right? So that's what we're gonna do right now. Maybe I give you a moment to dig that up, in case you don't have it with you. And also, we're gonna need the study guide for today as well. Let me post the link on in the chat box for you. We're going to be doing quite a few exercise from there today. Study guide is right here. Okay, so there's the study guide. If you haven't already downloaded a copy, please do so. All right, so just clarification of a few things before we add more things to this chart. We are actually going to add two more things here. Okay, we're going to add the antibodies in plasma. Okay, and over here, let's just be more specific. This is the antigens on RBC. Now, in case you need a little bit of refresher on the difference between antigens and antibodies, let me just write it out for you. Okay, so antigens are basically molecules found on a cell. Okay, not necessarily red cells only. You will find them in all cells. And it doesn't even have to be like human cells. You will find antigens on, bacteria. You will find antigens on virus. You'll find antigens on plant cells. Okay? So antigens are just molecules that are found on the cell. These molecules could be proteins, could be carbohydrates, could be glycoproteins, which are like sugary proteins, and so on and so forth. Okay? They're just things that are found on the surface of the cell. What we are talking about specifically in this case are antigens that are found on the surface of red blood cells, because that is what's going to be determining your blood type. Okay, so if you have antigen A on the surface of your red cell, then we say you have type A blood. If you have B antigen on the surface of your red cell, then you are type B blood, so on and so forth, right? So we don't you don't make antigens, so to speak, like they are inherited. Okay, whether you are type A or type B or AB, that depends on what kind of allele you inherit from your parents, right? So that's something that you are born with, right? I should say that, right? So these are inherited. You are born with it, okay? You don't get to choose. Now, antibodies are proteins produced by the immune system. And we'll learn how that actually happens next class. Antibodies are proteins produced by the immune system that targets foreign antigens. Okay, copy that down first. I'll explain a little bit more. So there are a couple of things to break down here. We have the foreign antigens. So we already know what antigens are. But it's also important to point out no two people are going to share the identical antigens. Okay, unless you have an identical twin, and that's a different story. But your antigens are not necessarily the same as mine. Okay, that's why we cannot just take anybody's kidney and then transplant it into someone else, because the antigens will be different, and your immune system does not like foreign antigen. Foreign means it comes from outside of the body, right? So anytime they see something that's foreign, anytime your immune system detects something that your body does not have, it will make antibodies and attack them. So if you do a kidney transplant randomly, the antigens on this foreign kidney are going to be foreign to your immune system. Then your body makes antibodies to attack them, right? But it doesn't have to be organ transplant. It could be, a bacteria coming into your system. And then your immune system detects foreign antigens on the bacteria, and then they will make antibodies to attack them. Okay, so basically, like in a very simple sense, your body is capable of making antibodies to attack anything that does not that you don't already have in your body. Okay, if it looks like something that's foreign, if it looks like something that's from outside, you will make an antibody to attack them. So that's antigen and antibodies. Does anybody have any question you want me to clarify? Okay. I'm still warming up. It's a little bit sluggish right now. Now, the antigens are found on the cell, and the antibodies are found in the plasma. Remember the plasma? If you spin down the blood, the liquid portion, the yellow stuff at the top, that's going to be your plasma, right? That's where the antibodies are going to be floating. So listen to me. If a person has type A blood, what kind of antibodies are they going to make? Well, since they only have A on the surface of their red cells, then B is going to be foreign to them, right? And so in the plasma, they will have antibodies, which by the way are Y-shaped, that would target B, right? So we call these anti-B antibodies. That's why you cannot take type B blood and give it to type A person. Okay, it's going to be incompatible. What about a type B person? What kind of antibody does a type B person have? Help me out here.
Anti-A.
That's right, anti-A, because A is foreign, right? A is foreign. If you're B, you have never seen A before inside the body. So A is going to be foreign.
Is it any reason you are putting this Y in a specific shape?
Yeah, the Y is the antibody. Antibody a Y shape. Okay, here I should specify here. Antibodies are Y shape. They literally are protein. Okay. So they're like little forks that stick onto things. How about someone who's AB? What kind of antibodies do they have? Do they have anti-A or anti-B? What do you think?
None.
None. That's right. Okay. No antibodies. Now I have to clarify here. When I say no antibodies, I'm talking about the blood group, right? Like the A and the B. I'm not saying the person cannot make antibodies for chicken pox or something like that, right? This is just talking about within the ABO blood group. Okay, what about O? What kind of antibodies will a person with type O blood make?
Anti-A and anti-B both.
That's right. Are the rest of you with me? The rest of the class? Give me some,
Yes.
yeah,
Yeah.
okay, thank you. Okay, please ask, okay, if you don't understand this. I'm trying to go as slow as I can. Right? Now, listen, there is no such thing as anti-O. Okay? What is type O blood? Type O blood is nothing, right? It's no A and no B. So you cannot make an antibody that targets nothing. All right? So that is that. Okay, we have one more column, which we're going to look at shortly. But first, let's write more notes. Okay, we're going to talk about RBC transfusion. Okay, remember I told you at the beginning of the lecture, not today, but like, Monday, you cannot just give blood directly from one person to another person, right? Like you got to separate them into plasma and red cells, and you actually would remove the white cells and the platelets. Okay, platelets can be transfused separately, okay? But the white cells, we cannot use the white cells. Okay, so I'm going to teach you the rules for RBC transfusion. We are only talking about giving the red cells. There are plasma transfusion as well, but the rules are different. I used to teach both of them to the class, but everybody got so confused and all the answers were wrong on the test. So I don't do that anymore. Okay, I'm just going to do RBC transfusion. Okay, so anytime you see a transfusion question on the test, I'm talking about RBC, just the red cells. Okay, so you spin it down, you take the hematocrit, that's what it's called, right? We learned that last class, the red cells, and then we're going to transfuse it to someone else. Okay? So there are three things you need to ask yourself, okay, to determine whether it is compatible or not. So question number one, you have to ask the antigen. You have to consider the antigens on the donor. The donor's RBC. The donor is the person who is giving the blood. So you have to figure out what kind of antigens they have. Number two, we have to determine the antibody. Antibodies in the recipient. In the recipient's plasma. Okay, the recipient is the person receiving the blood. You want to know what kind of antibodies they have. And number three, will the antibody attack the RBC? Okay, those are the three things you have to ask yourself when we try to figure out whether the transfusion is safe or not. Let's do an example. Can we give type A blood to type B blood? Okay. This is the donor. You can think about it, okay, whether safe or not. I'm gonna explain to you, okay? So is it safe or not? Okay, so let's draw this out. First question, the antigen on the donor's RBC. Well, that's easy enough. If you are type A, that means on the surface of the cell, you're gonna have A, right? And then the recipient, what kind of antibody does a type B person have? You can look at the chart or you can think about it. If you're type
A.
B, that's right, anti-A, right? So if you go ahead and give the blood cells to this person, that's bad news. The antibody will attack the RBC, right? Okay. Antibody we can say anti-A antibodies will attack. I'll tell you what happens when they attack, okay, later. Right now, we just want to figure out if it's safe or not. We'll attack the RBC. So that's not compatible, not safe. Does anybody have any question?
Why can't we just say that antigen should be the same instead of these three steps?
Say that one more time.
Instead of these three steps, we cannot say only the antigens should be the same for both recipient and the donor.
Interesting question. Okay, let's answer your question. Based on what you said, do you think this is safe or not, Mohammed?
Safe?
Okay, okay, say it's safe. Anyone else?
No.
No? Okay, so let's find out, right? Let's use the 3 questions and we'll figure it out. Okay? I'm gonna give everybody, I don't know, a minute. Right, let's try to draw it out like I did. And then, you know, we'll see if it's safe or not.
Not safe.
No, you change your mind?
Yeah, because it has both antibodies.
Okay, well, let's see. Okay, we'll give the class a few more minutes, a few more seconds, and then we'll take it up.
If you look antibodies, then it's safe because there is.
Oh, you change your mind as well?
Yeah, because there is no antibodies in AB now.
Okay. Yeah. Okay, let's do a poll, okay? Why don't we do a poll? If you think this is safe, A to AB is safe, choose A. If you think it's not safe, please choose B. Okay. No. Most of you think it is safe. Well, let's find out. So antigens on the donor, it's A. What kind of antibody does an AB person have? If a person is AB, they shouldn't be making anti-A or anti-B, right? Yeah, it's none. Because otherwise they would end up attacking themselves, right? You only make antibodies for things you do not have in the body. Okay, so no antibody. No antibodies. So that's why this is okay. That's why this is okay. You can give them A blood. No antibody will react. So this is safe. Okay? Everybody happy? All right. So this is cheat sheet. Everybody loves cheat sheet, right? I love cheat sheet. So you can put this on a sticky tag and stick it on the computer when you take the test. Okay. This tells you the compatibility. If you don't want to think about it, okay? If you're like, I don't care, I just want the answer, okay? Then this is gonna tell you who can give to who. But of course, I encourage you to understand it, right? Otherwise, when you become a nurse, right? Please tell me what hospital you're working at, and I'll try not to go there in case you give me the wrong blood type, okay? So, but this is the cheat sheet, right? It tells you A can give to AB, B can give to AB, right? See, everybody can give to AB. Why? Because AB has no antibodies, right? You give them anything, they'll take it. Within the ABO blood group I'm talking about, right? Don't forget, there are many different blood groups, right? Like 40 of them. Okay, so like within the ABO blood group, this is the compatibility. And that's why O is sometimes called, well, they are called the universal donor. Why? Why can you give O to everybody, seemingly? What's on the surface of O, guys?
Anti-A, anti-B.
Right. But then Tanya, we're not giving the we're not donating the antibodies, right? Like I'm saying, if a type O person is a donor, right? What kind of antigens will be on the surface of the cell? Let's try that
None.
one more time.
Nothing.
Nothing. That's right. And if there is nothing on the RBC, then other blood group can accept it, even though they have anti-A or anti-B. That's okay, because there's nothing attack. You have nothing to attack. To attack. Yeah, you have nothing to attack, right? On the O cells. Does that make sense?
Yeah.
Okay, what's the question? But how do they call A is not universal recipient. AB they call universal recipient. Okay, you look at this picture. AB can accept from everybody, right? You can accept from A, you can accept from O, you can accept from B, because AB has no antibodies, right? Do you understand that? Yeah, okay. All right. But I want to caution you, right? Severely caution you. The term universal donor and universal recipient is actually not correct. Okay, just because you're type O actually does not mean you can give it to everybody, because there are all these other blood groups you have to consider, right? O is only universal within the ABO. If that confuses you, that's okay. Hold on. When we learn RH, you will fully understand, I hope. All right, so we're going to come back to here. Keep the cheat sheet with you. We're going to use it throughout the class. Okay, maybe put it in your notes, somewhere you can see. All right, so over here, I'm going to complete the chart. I'm going to say, can donate RBC to ... So why don't you fill this in? Who can type A blood people donate red cells to? Okay. Again, I have to emphasize, we are only donating red cells. Okay, that's why I don't care about the antibodies in the donor, right? Because those antibodies are like taken away before the transfusion. And Mohammed, earlier you say, why can't we just look at the letters, right? So that's why, right? Because there are more than one possibilities, right? That's why you have to consider these questions. So who can A give to? Well, if you want to just look at the transfusion chart, A, follow the arrow, A can give to AB, right? You see? A can give to AB.
Sir, also
Yes.
A can give to A.
Exactly. Very good. Yeah, you just ahead of me. Okay, I see some people say they can give to O, they cannot. I'll show you. Okay, let's do this over here. Right, first of all, you have to follow the arrow. The arrow points to who you can give to. Okay? And whatever is pointing at that letter, it tells you who can give it to you. Let me say that one more time. The arrow, follow the arrow. The arrow tells you who you can give it to. The arrow that's pointing at the letter is who you can receive from. And of course, you can always give and receive to your same type, right? A can always give to A. B can always give to B. But I see, some people say A to O, right? Let's see what.
In this cheat sheet again, this O is that the donor or the recipient?
Okay, so you guys understand these arrow stuff, right? In this arrow, the first thing is the donor, the second thing is the recipient, right? Okay, so like depends what you're looking at. Let's say you're looking at this, okay? Who's the donor? Blessing, tell me, who's the donor in this thing that I circled?
O is the donor.
That's right. So it says O can give to AB. That's what it means, right? Do you understand now? Like if I look
Yes.
at this, then O can give to B, right?
Yes.
All right. So let's see, A can give to O, yes or no? Well, let's find out. What is on the surface of A? Well, A, right? What is in the plasma of a type O person? What kind of antibody in a type O person?
AB.
No antibodies.
Anti-A and anti-B? No, not no antibodies, right? If you are type O, look here, right? If you're type O, you have nothing on your cells. And because you have nothing on your cells, that means you have never seen A and you've never seen B before. That's why you have both anti-A and anti-B. Right? I didn't see who made that comment, but does it make sense now?
Yes,
Yes. Okay, yeah, thank you. So this is bad because look, anti-A and anti-B, right? This is not safe. Why is it not safe? Well, the B is not going to do anything, right? But then the A is going to attack, right? This is not safe. Does it make sense that you cannot give to O?
yes.
Yeah. Okay. So let's continue here, right? Who can B give to? Who can B give to?
So A, B, and B.
A, B, and B. If you don't understand why this is the case, then please ask, okay? It's only gonna get more confusing. That's what I say about everything. But this is true, okay? This is actually true. It's gonna get more confusing, so make sure you understand. Who can A, B give to?
Just AB.
Just A, B.
A,
That's right. So AB people say they're selfish, right? Because they can receive from everybody, but they can only give to AB. But like I said, that's not true. Right? It turns out the rules for plasma is completely opposite. If you are AB, you can give plasma to everybody. Okay? But you can only receive plasma from other AB. But we're not going to talk about that. You can think about why though. Okay. So I'm AB, right? If I need red cells, I'll email the class. Okay? But if you guys
Because
need
you have no
plasma, you can let me know, right? What's that,
Because there is
Mohammed?
no antibodies.
What's that?
There's no antibodies in plasma, so you can give it to everyone.
Exactly, right? Right. So it's very fair. Okay. O, who can O give to?
Everybody.
That's right. O, A, B, A, B.
But what is A plus B plus A minus B minus?
Yeah, we're gonna get to that. Don't worry. Yeah, it's coming.
Sir,
Yep.
I heard, I don't know how true, that if a person with an A blood type
Mhm.
give a person to blood to O, so if A gives to O,
Yeah.
then the person with the O blood type it will change their blood type to A. Is
Oh
that
no,
possible?
100% no. Blood transfusion will definitely not change your blood type. Okay. The only situation where you could change your blood type is if you receive a bone marrow transplant. Okay, so I think that may be what you're talking about. Let's say a type, but the bone marrow transplant has to be also compatible, right? Like you cannot give the rules for bone marrow transplant is pretty much same as the transfusion rules that we have here. Like type O can give bone marrow to type A, but not the other way around, right?
Mhm.
Okay, since you bring it up, right? So I actually had a student. She told me she had leukemia when she was younger, and she received a bone marrow transplantation. Okay, I don't remember what her blood type is, but after she received the bone marrow transplantation, because the bone marrow is where the blood cells come from, right? Remember we learned about that, right? The hematopoiesis, that big word, right? Okay, so when you receive new bone marrow, that is of a compatible but different blood type, or the new cells that comes afterwards could be a different blood type, and that changed her blood type. Okay, but you can change your blood type by receiving blood transfusion. It's only when you have a different bone marrow. Does that make any sense?
Yes.
Yeah. Okay, I know I keep on asking you guys, but seriously, any questions before we move on? Any other question?
I asked the question last week, sir.
About
the A's, right?
antibodies, yes.
The HIV. Yeah. Okay. But that's lecture 3. Long story short, the HIV is gonna kill your immune cells. They infect and kill the immune cells. They kill the ones that are going to be able to make the antibodies, and that's why they can't make it. That's the short version. Okay. But we're gonna talk more about it next time. Okay. What should we do now? Let's go back to the PowerPoint just briefly. Okay, I only have one slide that I want to talk about with you, and then we're gonna do the RH. So I'm sure you're dying to find out what happens if the blood transfusion is incompatible, right? What actually happens when the antibodies in the recipient attack the donor's RBC, right? So this picture pretty much shows the same kind of information I'm trying to draw for you, but instead of using letters A, B, C, they use shapes, which I think is a little bit confusing sometimes, but that's the best picture I can find, unfortunately. Now let's take a look at here. This top situation is showing what happens if you give type A blood to another type A person. You know it's gonna be okay, right? Because A can give to A. But let's take a look at what's going on here. So on the surface of a type A RBC, you have these antigens. So they use these balls, these circles, to represent A antigen. Right? So it's just a bunch of A's, okay? Which again, you would expect that to happen. Now, the recipient is also type A, so they would have anti-B antibodies. So if you take a look at the antibody here, like the fork at the end, it's like triangle, right? It's not gonna bind to these little circles, right? But like in our notes, we put a letter B here, right? So basically, if the letters are not the same on the cell as it is on the antibodies, then they will not react. So no binding, no reaction. It's a safe transfusion. Okay, if you mix the donor's RBC with the recipient's antibody in a petri dish, like in a lab, like in a dish, okay, you will see no clumping. Okay? The blood is not gonna come out. Let's take a look at the second situation. If you take type A blood and you give it to a type B person. So again, on the RBC, you see all these circles, they are just A's, right? And now the recipient is a type B person. That's why they have anti-A antibody. Look at the ends of the antibodies, right? They have these round ends, which will recognize and bind to the circles, right? Anti-A. Right? So when that happens, we call that a cross reaction. A cross reaction is when antibodies bind to their target. Okay, the target is the antigen in this case. And what's going to happen is that will cause clumping. Okay, clumping, another word for clumping is agglutination. Okay, that just means clumping, things like grouping together. Right? And you can see it in the dish. Okay? So all these little things here, these are clumps. Okay? And when the red cell clump together, the next thing that happens is they will undergo hemolysis. Hemo is blood, lysis is break. Basically, the red cells burst. Okay? And that's bad news. The person is already suffering from low red cell. That is why you have to give them a transfusion. And then you give them a transfusion and it causes more red cell to burst. You're not helping with the person's condition. And to make it worse, the person has to cope with all these incoming red cells that are bursting. So, they could potentially die.
Good question.
Mhm.
So when like the non-compatible blood cells are coming in, does the person like have like a fever? Are there any like symptoms, or is it just like
Yeah,
any
you
explosion?
will see that you will see their blood hemoglobin goes up like crazy
Okay.
because all the red cells are bursting, right? So all the hemoglobins are leaking all over the place, right? They will have anemia. They probably is experiencing a little bit of anemia already because of the low blood count. But then when all these things are coming in, they would have extra anemia. You will see their white cells go up because they're trying to fight off all these incompatible red cells coming in, right? It's something that's easily identifiable when they look at your blood work.
Is there a way to correct it or no?
Yeah, this is my question. Can you fix it?
You can flush it out with the right blood, okay? But you got to do it quick, okay? You got to do it quick, right? So as soon as you realize the mistake, you try to clear out the wrong blood, right, with the right blood. You could fix it sometimes. Okay. All right.
What about the times you can't fix it?
Then the person might die, unfortunately. Yeah.
How like often does this happen though? Like someone makes like a pretty big mistake.
I don't have the statistics, but I would want to say it's more frequent than it should be.
Uh-oh.
Yeah. Okay, so like again, right? Like back to the movie situation, right? Okay, movie situation where you see the guy hook up the blood to the other person, right? Okay, you see this a lot. Every time me and my wife watch a movie and then this scene comes up, we're like, oh, so stupid, right? So you will see the person say, oh, I'm type O, I will give you my blood, and then they will literally hook it up and give it to the other person, right? So let's say the other person is A, okay, and just because you're O, sure, you can give O RBC to a type A person, but if you hook it up directly to the other person, your antibody is going to be going over as well, right? And if you're a type O person, what kind of antibodies do you have?
Both.
Yeah, both, right? Am I the only one who is excited here? If you're type O, you have anti-A and anti-B antibodies. And if that goes into the other type A person, then you will attack their red cells as well. That's why it doesn't work. Okay, that's why it doesn't work. Even if you are both type A and you do a direct line transfusion, it's not a good idea because your white cells will go over as well. Okay, and then what's in that person's body is definitely different than what's in your body. So your white cell is going to attack stuff all over the place as well. Okay, so it's just not realistic. All right, moving on. Next, we're going to talk about the plus, right? Last time I asked you guys what was your blood type, and you're like, oh, I'm AB plus, I'm O negative, right? What is the plus? What is the negative? That is an other blood group, okay, called the RH blood group. Right, so remember, there are 40 different blood groups. We learned about ABO. Now we're going to learn about a different one called the RH blood group. It's named after the monkey that was first discovered. That named after the monkey that the blood group was first discovered. So they discovered this blood group in the rhesus monkey. They call it RH blood group. Okay, interestingly, RH is only found on RBC. So when it comes to organ donation, you only have to worry about the ABO blood group. Okay, you don't have to worry about RH condition. Right? So I'm gonna give you a really long note on RH. So brace yourself. Give me a second, my mouse just ran out of battery. So, RH. Let's talk about what it is and the genetics behind RH. And then I will talk about transfusion related to RH, And then we'll talk about what happens if the mother and baby has mismatched RH. Right? So that's gonna be like 45 minutes. So RH blood group. So a person is RH positive if RH antigen are found on RBC. There's the RBC. If we have RH on them, then is RH positive. RH negative if RH antigens are absent on RBC. Okay? So like this, nothing. Whether you are positive or negative has nothing to do with whether you are A, B, or O. Okay, one thing has nothing to do with the other. They are two completely different genes. Okay, and last semester we learned about independent assortment, right? How one gene gets sorted into the gametes has no influence on how another gets sorted into the gametes. So let's draw some RBC. Okay. Draw A positive RBC. Right. A positive RBC. So here is our RBC. Right. Red blood cell is the happy face without the eyes. And A positive, what does it mean? You know, it means the person has A. You can continue to use color if you want, okay? It's just easier for me to keep it black and white. And it's positive, so it has RH. Those are the only two things, right? If we only focus on A, B, O, and RH. Okay, let's try another one. Can you draw AB negative, please? AB negative. I'll give you a moment.
It will be only AB on it.
Only AB, yeah. That's good. So AB negative. A means there's A, B means there's B. Negative means no RH, right? Okay, one more. Anybody want to tell me what to draw for O
Only
positive?
RH.
Sorry, what's that?
Only RH.
Only RH, that's right. O means no A, no B. Positive means just RH, right? That's all. So that's what RH blood group is. You either have RH or you don't have RH.
So sorry, what is RH again?
It's just a protein, right? It's just a
Oh,
protein. We call it the RH protein, the RH antigen, right?
So people that have A positive,
Mhm.
they have the RH
Yeah, they have the A protein and then they have the RH protein,
protein.
basically. Yeah, or we can say antigen. Okay, antigen
So
is
what
just
is-
stuff on the surface, right?
What does RH stand for anything?
Yes, so in the PowerPoint slide, RH stands for rhesus. It's the monkey that it was discovered in, right?
So does monkey have RH blood?
That's right. Well, I mean, some of them do, right? And the ones that don't, they would be RH negative, right? Okay. Yeah. But the point is they discovered this in the monkey first. So they name it after the monkey. That's all.
Oh, I thought that. Okay. Okay.
You sure? Yeah.
Yeah.
O negative will have nothing on the surface.
That's right. Okay. So O negative is like this. Now, I have to keep on bringing back this point because people get confused after a while. O negative, you said there's nothing on it, right? So there's no ABO, there's no AB, no A, no B, and then no RH. But remember, there are 40 different blood groups, so they might have other things on the red cell, right? Okay. Someone who truly has nothing on their red cells is super, super, super rare, but they exist. And if you are one of those people, the Canadian Blood Service actually encourage you to regularly go in and donate blood. Because if you're truly absolutely negative for all the blood group, then no one can give you blood except for other people that are also like that, right? So the blood is super rare that they encourage people to go and donate blood and regularly keep a healthy bank, right? Otherwise, if people like that needs blood and they can't find a suitable donor, the person is in trouble, right? Okay, so when we say O negative, in the context of what we're saying, we're just saying the ABO is negative, and then the RH is also negative.
What is that super blood rare type called?
I think it's just called like no as in like nothing at all. Okay. But it's not a single blood type, right? It's like they don't have any of the 40 blood groups.
Okay.
Okay, so like for example, and another blood group is called Cal. So you can be Cal positive or Cal negative. So this person might be negative as well. And then if you look at another one called Duffy, they might be Duffy negative. So if they are negative for everything, then they truly have nothing on the red cells. And it's really hard to give them any compatible stuff, right? Okay. Genetics. Genetics of RH. Okay, it's very simple. Compared to the ABO, there are 2 alleles. Right? The positive and negative allele. Positive allele. Allele is different version of gene, right? Allows a person to make RH. Negative allele does not make RH, right? So you either have the recipe to make the RH or you don't. Only 2. So 2 alleles, 3 possible genotypes. You can be positive. That means both of the copies are positive. That just means you can make RH, right? So the person would be RH positive. Okay. What's another possible genotype?
Positive, negative, and negative, negative.
That's right. So positive, negative is heterozygous. Negative and negative is homozygous. Does this person have RH? Are they positive all for RH or what?
Which one is dominant?
Okay, interesting question. Just hold that thought. Anyone else? What do you think here? Would the
Between
person?
R positive.
Okay. Anyone else? Okay, let's do another poll, just to be safe. My question is, if you inherit a positive allele and a negative allele, will you be RH positive or RH negative? Read what I have here.
I think one genotype has an option to make it, so it will still make it, even if the second one does not.
That's good, right? So this is back to the cookie cutter analogy, right? You can have 2 cookie cutters, but you actually only need 1 to make the cookie, right? So if one of them is positive, then the person is also going to be positive. Okay, here, I'll put a star here. Just 1 copy of the gene is enough to make Rh. All right. And what about negative, negative? Well, if they're both negative, you do not have the recipe to make Rh. So this is Rh negative. Okay. I found out one semester that some people are confused about this because they're thinking about math. They're like, oh, negative times negative is positive. This has nothing to do with math. Okay? Like, if that is the reason why you're confused, then, you know, stop thinking that way. Okay, that's the genetics. Let's talk about blood transfusion. Okay, blood transfusion. So, RH. Okay, actually, you know what? I should ask you guys to think about this. Who has the potential to make anti-RH antibody? Okay. Who can make anti-RH antibody? Is it the positive people or the negative people?
Negative.
Who too fast? Who makes anti-RH antibody? Okay. Please think about this. Is it the Rh positive people or Rh negative people? Okay. Well, just keep it in your mind. So let's backtrack a little bit, right? What is antibody? Antibody are the things that you make to attack things that you do not have. If you are positive, it doesn't make sense to make anti-Rh antibodies, right? Because you have positive, you don't want to end up attacking yourself. Okay. So it's the negative people, right? So Rh negative people can make anti-Rh antibodies. Okay. There's a little catch here, an important catch, but we will come back to it in a bit. Okay, for now, that's just it. So back to the compatibility chart. Okay, that is for ABO. And then for RH, negative people can give to positive people, but not the other way around. Okay, not the other way around. Okay, give me a moment. I'm gonna pull up the study guide here. And I want to do number 7 with you. I'm not gonna do all of it, okay? But like I'll do a few. And then you can do
So
the rest.
how Rh negative can give to Rh positive? It already has the Rh antibodies.
Okay, so here again, it goes back to the question. It goes back to the concept that when we do blood transfusion, do we give the whole blood?
No.
No, only what?
RBC.
That's right. So when you do that, the antibody is not gonna go over, right? Does that answer your question?
No, but it happens. The Rh is in the blood, right? And RBC.
The Rh is on the RBC, right? So this person has no Rh on the RBC. So that goes over and this person has no antibodies, right? So that's okay. However, if you have a Rh positive and you go this way, then this person have the Rh antibody, right? And that's why this is not okay, right? Does that make sense?
Yeah.
Yeah, okay. All right, this is number 7. I'm gonna do a few for you, okay? So first one, we have A positive. So who can A positive receive from? You should look at them separately, okay? So let's look at the A first. Who can A receive from? So A obviously can receive from other A's, right? But they can also receive from O. Whatever arrow is pointing at them means it is compatible. If you are positive, you can receive from other positives, but you can also receive from other negatives. Look at the chart. Negative can give to positive, right? Who can A positive donate to? Well, A can give to other A's, and they can also give to AB. But if you are positive, you can only donate to other positive people. Okay. Please try the next couple ones, okay?
I have a quick question.
Mm-hmm.
So if I'm like A plus and I'm getting like A negative, like the exploding thing won't happen. It's all
That's
like
right. Because
good.
A and A is compatible, right?
Okay.
And then
So in this
negative
case, the
can give
negative
to
positive.
that's right.
Okay.
Yeah.
Okay. Thank you.
Mm-hmm. Yeah, the exploding thing, by the way, is hemolysis, okay? Yeah, I'm sure you know that, but I just want to say it. Okay, please fill in the chart and, ask questions along the way.
You can just look into the cheat sheet and answer the questions.
Yeah, you can. Yeah. Okay. So if you want to just use a cheat sheet, no problem. But it's good to do the mental exercise as well. So I'm going to take up the second one, huh? If you're B positive, you can give it to B. Sorry, you can receive from B. You can receive from O. And because you're positive, it's good. You can receive from both positive people as well as negative people. B can donate to B and AB, but because you're positive, you can only give to other positives. Okay. I'll do one more. Actually, you know what? I'll do this one. It will show a point. If you are O positive, who can you receive from? Well, if you're O positive, you can only receive from O
O positive and O negative.
positive and O negative. That's right. And who can you give to? Well, you can give to A, you can give to B, AB, as well as O, right? But only to
All positive.
positive people. You see, I just proved to you O is not universal donor. is only universal within the ABO. As soon as you take into consideration of other blood group, they are no longer universal, are they? For example, O positive cannot give to A negative, right? O positive cannot give to O negative. Do you understand that?
I have a quick question.
Mm-hmm.
So referring back to the medical dramas like you're talking about,
Yeah.
always you're like, oh, I need O negative. Like, is that because it's better than O positive?
Now
Like,
that is a very good question. Okay. So in an emergency situation, life and death situation, okay, the guy is bleeding out. If we don't give them blood right now, we're gonna lose him. Okay, he's gonna die. In a situation like that, we don't have time to test for all 40 blood groups. Okay, so what's the best blood to give to them? What's the blood that is most likely to not cause a problem? What's the blood? O negative, that's right. Okay. The other blood group typically are not as much variation in the population. Okay. And there is something else that I have to teach you, maybe after the break, that kind of gives you like a one free chance. I'll explain what that means, okay? To get it wrong. You have one chance to get it wrong typically, and the person will be fine. I'll explain this afterwards, okay? So which is why in a situation where it's very emergent, right? Then you give them O negative, and typically is going to, like the benefit of receiving the O negative will outweigh the risk of getting it wrong. Does that answer your question, Medicine?
okay, yeah, thank you. Sorry.
Hey,
Okay.
Misa.
Yes, Tahib, go ahead.
So is AB plus like it's like all blood types, right?
Can receive from, yeah. If you're guys, if you're AB plus like me, we've hit the jackpot. Okay, we can get it from everybody, everybody. Okay, for RBC, of course, I'm talking about. Remember, rules for plasma are different. Okay, and you can only give it to AB positive. Okay. Now I don't want to drag this out, but I will do one more. I'll do a negative for you, okay, just to see how it is. If you're A negative, then you can only receive from the negative people. Okay, you cannot receive from the positives. And who can you donate to? You can donate to the positives as well as the negatives. All right. So that is that. Now, let's take a quick break. But you know, if you don't need a break, you can try this question. This is number 8 in the course in the study guide. Okay, try not to use the cheat sheet. If you have to use it, fine. Okay, but like try to push through, think it through. Okay, these are the donors on the left side, and these are the recipients. Right, like, can you take this blood and give it to this person? Safe or not safe, right? Okay. Why don't we come back at 9:40 maybe? 9:40-ish. Yeah. And then we'll take this out. Okay, see you in a bit. All right, let's keep going. We still have quite a bit to do. So maybe you had a chance to work on this, but let's take it up. When we do something like this, we have to look at the ABO compatibility and the RH compatibility separately. Okay, both have to be compatible for it to be a safe transfusion. So this is the type A person, and this is a type AB person. Even though A can give to AB, but positive cannot be given to negative, right? That is why this is not safe. Okay. In fact, this whole row is going to be not safe. Okay? Because again, positive cannot be given to negative for the second one, and A cannot be given to B anyways. And for the last one, A cannot be given to O. So that's why it is not safe. So it's no, no, no for the first three. Okay? Just stop me if you need me to explain why something is safe or not safe. Huh? Okay, next one. Not safe because positive cannot be given to negative. Same reason. And then this is also not safe because B cannot be given to O. Right? Look at the cheat sheet. All right. O negative can be given to all the people here. So safe, 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 safe. Okay. AB negative. Nope. And then no and no, because AB can only give to other ABs, right? And over here, it is the same blood group, so that is safe. Any of these you need me to explain? Just let me know which one. Okay. What is next? Okay, let's do this pregnancy thing. And next we're going to talk about RH sensitization. Okay, RH sensitization. So, oh, I have a question here. O negative can be given to anyone, but not O positive? No, negative can give to positive. Okay, if you are negative, look at here. Right? Negative can be given to positive. Because when you're Rh negative, there is nothing on your red cells. And then when you go over, there's no antibody to attack anything, right? That's why it's okay. Is that okay? All right, RH sensitization. I need to backtrack a little bit and explain something to you. So I already told you this, but let's go through it again mentally. Okay. A person who has type A blood, person, what kind of antibodies do they have? You can just think about it in your head. Okay. A type A person, what kind of antibodies do they make?
Type B.
Anti-B, right? Anti-B. For all intents and purposes, these people are born with the anti-B in them. Okay? When a type A person comes into this world, they already have anti-B antibodies in them. Okay? Same thing. If you're a type O person, as soon as you come out, you already have anti-A and anti-B. Okay? That's not entirely accurate, but for our purpose, it's going to be okay. All right? However, this is not true for RH. This is not true for RH. A RH negative person can make anti-RH antibodies, but only after they have been exposed to RH positive blood. I'll write it down for you, but I just want to explain it to you first. It's the same concept as this. When you are born, you do not automatically have anti-chickenpox antibodies, right? When are you going to make anti-chickenpox antibodies? After you caught chickenpox, right? Or after you have a vaccine against chickenpox, right? So you don't automatically make these antibodies until after you get exposed. Okay? ABO is different. ABO, you're born with those antibodies. But when it comes to RH and other stuff, you have to be exposed to it first. Okay. So RH negative person, or RH negative person will only produce anti-RH antibodies after they are exposed to RH positive blood. Okay. Once exposed, the person is now sensitized. And their immune system will produce anti-RH antibodies. Okay, there is no going back. Once you are sensitized for life. Okay, those antibodies are going to be in your system. You cannot unsensitize yourself.
So you are saying that an RH negative person got a blood transfusion from the RH positive person?
That's right. That's actually my next question. Okay, that's one way how a person can get exposed. Okay.
But it will not start bursting the cells because the body has RH and now it creates the RH antigen.
Say that one more time. The sentence. I just want to make sure.
Will it not call homeolysis because
yeah, that's right. I'll explain that again. But you're right, absolutely right. Okay, so the next logical question is, how does a person get sensitized, right? For the RH. So I just want to reiterate again, only negative people can get sensitized, right? If you're positive, then there's nothing to sensitize to. You already have RH positive. You don't want antibodies in your system, right? Because otherwise you would attack yourself. So only negative people can get sensitized. So how does a person get sensitized? We're going to look at two ways. Number one is what Mohammed already mentioned, blood transfusion. Okay, RH positive blood given to RH negative person. Sometimes that's done by mistake. Sometimes it's done deliberately because they have no choice. Okay, maybe in some remote area, the hospital doesn't have any negative blood available. The person really needs blood right now. We know from medical history, for example, or from testing, that the person had not been previously sensitized, then it's okay to give them positive blood one time, right? Let me say that one more time. If a negative person had not been sensitized previously, then it's okay to give them positive blood one time. Right? This will sensitize them. They will start to make antibodies. So next time is not okay. But this time is fine. They don't have the antibodies yet. They can accept the positive blood once. And that kind of goes back to Madison, your question, right? Like in the TV shows, O negative, is it okay to give it? Yes, in an emergency situation, right? Because all the other blood group, you kind of have one free getaway ticket. right? You might sensitize them, but they will not reject the blood the first time. Okay. But in an ideal world where medical records are like centralized, they have to document these things. So when the person when the doctors or whatever pulls up the record and they see, oh, this person already used up their free chance. They already received positive blood previously. We should not do it again. Okay, because the second time is gonna cause problem, right? Second time is gonna have hemolysis. If the person already got sensitized, they will have antibodies in their plasma. They will reject the positive blood the second time. Do you understand this? You as in like all of you?
Yeah.
Yeah. So you
Well, I
can get
don't-
away with it one time. But
But
not the
why-
ABO stuff. Sorry, yeah. Not the ABO blood type, right? You cannot get away with the ABO. Because for the ABO blood type, you are born with the antibody, right? You can get away with RH because, you are not born with the antibody. Yeah, Patricia and then Mohammed, please.
So if
Okay,
you
so
Yeah, Patricia first, please. Sorry.
okay, so the RH means a person, so A positive,
Mhm.
it's a person with RH.
They have RH and they have A.
RH. Okay, so are you saying a positive person cannot give to a negative person? It will change their.
Okay, so here's the thing, right? Okay, yeah, this is a common misconception. So A positive give to A negative. Okay, A positive give to A negative. It's okay to do it one time,
Only one time.
only
Okay.
one time. But once you give the positive blood to the negative blood, you will sensitize them. You are not changing their blood type in any way. Okay, the A negative
Mhm.
person will stay as A negative. Okay, but when you sensitize them, they will start to make anti-RH antibodies.
Okay.
Okay, so the next time you give them positive blood again, they will reject it.
They're
So
rejected. And what
the
about
second
the other
time,
way around? What about the A negative?
negative to positive is okay. Remember, if you
Negative
are
to
positive, you already have
already
RH.
have the. Okay.
Yeah, and if you already have RH, you are not gonna make anti-RH antibodies, right?
Yeah,
You
because you
you
already have it.
That's right. You only make antibodies for things that you do not have, which
Yeah.
is why it's not possible to sensitize a positive person.
Okay.
Mohammed, please.
But once you make antibodies, will it not start attacking the blood itself?
Excellent question. Okay, um, we will learn this next week. It turns out you make antibodies, but you don't make it so quick, right? Think about how long it takes for you to recover from like a cold or even from COVID, right? The antibody will come, but not right away, right? So by the time you make the antibody, it's already maybe a week or 2 weeks later. Okay, so by that time, the blood cells would have been cleared out of your system already. You would have been okay by then. Does that answer your question?
Yeah, thank you.
Anything else?
Yes, so if the blood cells are cleared out your system and the A give to the negative person again,
Mhm.
why would it attack your system if the blood cells are cleared?
Okay, so blood cells are cleared, like the donor's blood cells are clear, right? But the antibodies that
It's
you've
still in their
made,
body.
that's where will stay with you for the rest of your life, right?
Okay.
And that's why you don't get chickenpox again if you got it, because those
Mm.
anti-chickenpox antibodies, they are still in you.
Mm,
It's hard
Okay.
to believe, but they are. Okay. All right. Very good question. Okay, what's another way for a person to get sensitized?
If the mother is pregnant and the baby has the antibodies
Okay, yeah,
and
you are on the right track. Okay, so I'm gonna write it out for you. Thank you. The second way is if an RH negative mother carries an RH positive baby. And then I'm gonna draw some pictures to explain this to you. Okay, it's a big picture, okay? So like maybe start a new page. Okay, so consider a couple. Okay, so we have the woman. We will say she is negative. So negative, negative. Right, so that means she's Rh negative, right? And just to keep it simple, I'm gonna say the man. The man is positive, positive. Okay. We can do it with positive / negative as well, but then just to keep it simple, we can do positive, positive. So what kind of baby are they gonna have? What's the blood type for the baby? Just the Rh alone.
Positive.
Yeah, positive / negative, which is Rh positive, right? 100%, yeah? 100%. Okay. Let's draw some pictures. This is the mother's blood. Let me draw it in the same order as the notes here. Okay, mother is on the top. Mother's blood, yeah. And then this is the baby's blood. Baby's blood. Okay, the baby is still in the mother, okay? This is during pregnancy. What separates the mother's blood and the baby's blood? Anybody?
The umbilical cord. I don't
The
know.
umbilical cord connects the mother and the baby, but there's this thing also comes out after the baby came out, right? Like, do you guys know what I'm talking about?
Oh, the
Placenta.
That's right, the placenta. I know about this. I know the placenta is gonna come out, but the first time, like when my wife gave birth, I was not ready for it. The baby came out. I was looking at the baby, and then I saw another thing came out, and I said, "What the hell is that?" And then the doctor was just like, "Oh, it's just the placenta." I was like, "Oh, that was a dumb question." I knew it, but then when I was there and I saw it at that moment, like I was just like so shocked. Like it's like bloody and all that stuff coming. I thought it was like abnormal, and I thought something was wrong with like my wife was hurting or something. But turns out it was just the placenta. Anyway, the placenta separates the mother's blood and the baby's blood. Okay, and again, for those of you who don't know, after the baby comes out, the placenta also comes out. A random story as well that I just remember this story that I read on the news one time. I think it was a couple years ago, like maybe 3 4 years ago, 2 3 years ago. I don't remember, but you can look this up. This happened in Toronto. So the police they found someone called the police because they found some human remains at the park. Okay, so the police came and then they saw it and turns out it was a placenta. Okay, and then the police was concerned because they thought someone gave birth at the park, and then they left the baby somewhere. Okay, so they tried to search for the baby. They couldn't find anything, so they put out this broadcast and say, keep an eye out. If you live in the area, keep an eye out for the baby. Because we found a placenta, we want to try to save the baby because the first 24 hours is very critical, right? If you're a newborn. And then this woman came forward and and she was like, "Oh, it's my placenta," but it was like from 20 or 30 years ago. So what happened is she gave birth, 20, 30 years ago, and at home she chose to give birth at home, and she wanted to keep the placenta. Okay, so she put it in the freezer, and she forgot about it. Okay, and I guess 20 years later, when she cleared out her freezer, she saw the placenta, and she thought it was a waste to just throw it away, and she wanted to, return it to nature. So she left it at the park, thinking that the coyotes would come and eat the placenta. But then it causes all this drama, which is I found it very, very interesting to read the story. You can look it up and and see for yourself. Anyway, I went on a tangent. Let's go back to this sensitization business. So the placenta separates the mother's blood and the baby's blood. Now, in this case, the mother is Rh negative. So I'm going to draw her blood cells. Okay? And we are only focusing on the Rh here. Okay, we're not looking at the ABs, just focusing on the Rh. So there's no Rh on the mother's blood, right? Let's draw the baby's blood. Because of the positive from the father, the baby is gonna express Rh, right? And this is gonna be the first pregnancy. Okay. First pregnancy. Now, it is possible for the placenta to get damaged during pregnancy. Okay, sometimes it happens, during the pregnancy itself, but sometimes it happens during delivery. Okay, so let's say the damage happens during delivery, and the placenta has some tear in it. Right? And what happens is the baby's blood is going to be able to cross the placenta and go into the mother's blood, right? But only if the placentas are damaged. Okay, it's not gonna get damaged for certain, but it certainly could happen. But when it does, then the baby's blood is gonna go into the mother's bloodstream. Okay. So what will this do to the mother? She is gonna be, what's the word?
Sensitized.
That's right, Megs. She's gonna be sensitized. What does that mean? It means her immune system is gonna be activated now, and she will start to make anti-Rh antibodies. Okay, so once sensitized, she will make anti-Rh antibodies. Is this going to harm the baby? The answer is no, because it takes some time to make the antibodies, right? If the damage of the placenta happens during delivery, the baby will be out of the mother by the time the antibodies are created, right? So if the placenta is damaged during delivery, the Rh positive baby blood, baby RBC, enters the mother and sensitize her. The mother will make anti-Rh antibodies. This will not harm the baby because by the time the antibodies are made, the baby is already delivered.
But professor, it should not affect baby anyways because Rh positive can get from the negative.
Yeah, hold that thought. We will find out what happens. Okay.
Quick question.
Mm-hmm.
On the second line from the top, the mother will make, I can't make out the word.
Oh,
The fourth word.
Yeah. The mother will make anti-Rh. Sorry.
Anti-RH. Okay, thank you.
Yep, we're gonna talk about a second pregnancy soon. Yep, I just waiting for people to finish copying this.
Quick question, sir.
Mhm.
Is it possible for the placenta to get damaged while the baby is still in the womb? Maybe like 7 months
Yes,
pregnancy.
exact. Yep, yep, yep. So sometimes this could happen in the second trimester, third trimester, and in that case, as you will see, it will be a problem for the baby. Okay, so interventions will be needed. But to keep things simple, right? I'm trying to, you know, say that the placenta damage during delivery. Okay. We'll talk about solutions for this as well. Okay, like there are medications you can take to stop this from happening. Okay, just hold on. We're almost there.
Sir,
Mm-hmm.
the interesting fact about my family
Sure.
is that all the women,
Mhm.
including from like my mother, my grandmother, their mothers,
Mhm.
are all O blood type,
Okay.
and including my aunts and their children,
Mhm.
and my mother's O,
Okay.
except for me and my brother, we're A. So
So
when my aunts found out that my blood type was A, they were really shocked
Mhm.
because the lineage, it's all O blood type.
Okay, but based on what you tell me, you're just telling me about the women in your
Yeah,
family, right? But
all
it
the
also
women.
depends on the men as well, right? If the woman is type O and they marry someone, let's say type A, and if that person, like for example, if your father is type A, he could be IA little I, right?
Mm-hmm.
So there's a 25%, there's a 50% chance actually that
My blood type would be A.
would be A, and then exactly
It's
50% chance.
crazy. I feel a little bit left out.
No, you're the special one. You're the one that stands out. Depends how you look at it, right?
Yeah, I
Okay,
get.
so let's take a look at the second pregnancy. Okay, second pregnancy. This is interesting stuff, guys. I hope you find this interesting. This is, very applicable in real life. Uh, the stuff that you learn in classroom actually has a real life implication. So I hope you are enjoying this. So this is the second pregnancy, and this is the mother's blood again. Okay, now assuming the mother is the woman is gonna have the baby with the same partner, because the partner, the man is positive, then it's guaranteed their second child will also be positive, right? And if you do the Punnett square, it's 100% positive / negative, which means it's going to be Rh positive. Okay, so this is the second baby, and it's also an Rh positive baby. Baby's blood. So mother is still negative, and this baby, again, it's positive. So what changed? What changed? Well, we have the mother's blood, and we have the baby's blood. Okay. What else should I add to the picture? What is different this time compared to the previous pregnancy?
Anti-RH antibodies.
That's right. There are anti-Rh antibodies in the mother system, right? That was not there the first time, but they are here now. Okay, so this is from previous sensitization. Okay, the first pregnancy. So that's going to be a problem for the baby because these antibodies will cross the placenta and it will attack the baby's blood. Okay, this is going to be a problem for the oh, sorry, not here yet, for the baby. Okay, because they're going to cross the placenta and attack the baby's blood. Okay, I think the program's going to crash any moment. Hold on. There we go. I have to turn off my video, okay? Because it's very laggy. You don't need to see me. Oh, I turned this on. There we go. Okay, so let's see if it's better. Okay. So the anti-RH antibodies from the first pregnancy will cross the placenta and attack the RH positive RBC of the baby. This is the second baby we were talking about, right? First baby is already out, not a problem. So what's going to be the problem? Okay. So if sensitization is not prevented, okay, like in future pregnancies, the baby is going to be born with hemolytic disease of the newborn. And there's like a fancy name for it, okay? But we can just call it HDN. It's important to realize hemolytic disease of the newborn is not restricted to RH incompatibility. Okay, all the blood groups can have this problem. Okay, the symptom severity can vary. Okay? Sometimes it could be very severe for some blood group, other times it's kind of mild. But the symptoms include anemia, which is what you would expect. We're talking about the baby, right? Not the mother, right? The mother is fine. The baby's going to experience anemia because the blood cells are being destroyed by the antibodies. They might have jaundice because when the RBCs hemolyzes, it releases the hemoglobin, and then the hemoglobin get broken down into the bilirubin. We learned that last class, and that's the yellowish pigment, right? The body cannot get rid of it fast enough. It builds up in the body, and there's this yellowish tone to the skin. The liver and the spleen are enlarged because they're trying to cope with breaking down the red cells. Okay? Remember, when the red cells die, that's where they go to, right? The liver and the spleen. So they're enlarged. And there is going to be severe edema. Edema means swelling. Okay, this goes back to the osmotic pressure discussion we had before, right? So this is your blood vessel. Remember, you have all this stuff inside the blood vessel that keeps the water, keeps the fluid in the blood, right? And a lot of those black dots are plasma protein, sure, but also the cells. Remember, the red cells makes up 45% of your blood volume. So if your red cells start to burst, then your osmotic pressure gets reduced and fluids start to leak all over the place, and that results in edema, right? So like I said, the disease severity varies, okay, depending on what the mismatch is. Do we have any question? Okay. So these are my babies. The left one is the older, is the younger one. The right one is the younger one. Both of them were born with jaundice, right? Not because of RH mismatch, but because of ABO mismatch. Okay, so I am AB, I told you already. My wife is type O, and both of my kids, they are type B. Yeah, they're type B. So this is my wife, okay? So what kind of antibodies would she have if she type O? Anti-A and anti-B, right? So these antibodies can actually cross the placenta as well and attack the baby's blood. But the severity is relatively mild compared to something like RH mismatch. Okay, RH mismatch, it's very, very severe when it comes to the antibody attacking the cells. Okay, so they were super jaundiced. And you know, for the way to kind of help with that is to put them into these chambers. Any mothers here? Do you know what this chamber is? Maybe, perhaps.
Provides the light.
The light. Yeah, what does the light do? What kind of light is it? Do you guys know what kind of light is it? Bluish?
Blue.
Yeah.
No, light. White.
White light? Yeah. This is
Like I know, but I don't know how to explain.
Like
that's okay.
sunlight.
This is UV light, guys. Okay, this is UV light.
Yeah, UV light.
Yeah, ultraviolet light. Okay, so the UV light is gonna help break down the bilirubin for them. Okay, it used to be people just say leave them out in the sun. Okay, in the sunlight, and the sunlight is gonna help get rid of it. But you know, if you're born in the winter, then there's not much sunlight, right? So they have to be put in these BD lights. You know, as you can tell, they are quite comfortable in there. The thing is pretty warm, and they have to wear these eye patches because the UV light is bad for the eyes, right? Okay, and we would feed them in the chambers and so on and so forth. And they were okay after some time. So you know, when the baby is jaundiced, one of the important thing to do is to keep them hydrated. Okay, in these mild cases, you want to keep them hydrated. You want to feed them as often as possible so that they could pee out the excess bilirubin, right? But then for the first baby, and you would know this if you are a mother, right? Sometimes the milk doesn't come in like quick enough, so to speak. Okay, and in Canada, they really like to encourage you to breastfeed. And so, you know, that's what we try to do. My wife tried to breastfeed the baby, but then the milk wasn't really sufficient. And so the baby was my older daughter was actually kind of dehydrated and wasn't able to get rid of the bilirubin, and so she turned quite yellow after the first 24 hours. That's why she had to go into this Billy Light. And so, you know, I called my mom and I told her what happened, and she's like, "Oh, don't listen to them, right? Like just feed her formula, for goodness sake, right? All of you were raised on formula, and look at you, you grew up fine. Just feed them the formula." Right? And so that's what we did. Okay, we feed her the formula. And as soon as she gets the formula, as soon as she gets the hydration, she was able to pee it out very, very quickly, right? Okay, and she was fine. So comes the second baby. Okay, second baby, we're like, oh, we're ready for this. Okay, let's stock up on the formula. Okay, if the milk comes, great, we'll breastfeed the kid. But you know, if not, we got the formula. We're ready for this. But you know, life is full of surprises, right? When the second baby come, she didn't want to come out. Okay, she didn't want to come out. And for those of you who don't know this, when babies don't come out, you try to use a vacuum to suck them out. Okay, I was just telling my younger one the other day that, you know, you actually need to have a vacuum to suck you out, and she was horrified. She's like the vacuum that you use to clean the house, right? That's what she thought, right? But no, it's like a medical device, right? Obviously. But when you suck them out with a vacuum, it leaves a big red bruise on the forehead. Okay, and anytime you have a bruise, is basically a lot of red cells dying. Okay, so not only is she dealing with the jaundice from the ABO incompatibility, she was like even more jaundice than the first baby, because of the hematoma, because of the bruise from the vacuuming. Okay, so she was in there for like almost a week to get rid of the jaundice. Anyway, so when you have the incompatibility of blood, you know, we might have a mild cases like this, okay? But if it comes to RH mismatch, it is much more serious, and you know, there are intervention that needs to be taken to help recover as well as to prevent it from happening. So how do you prevent it from happening? That's what we're going to talk about next. Okay. So next part of the note, preventing RH sensitization. Okay. There is something called ROGAM. ROGAM. Okay. So ROGAM is an artificial anti-RH antibody. Okay, it's man-made, it's made in the lab, and it targets RH. Okay, it's man-made, and it targets RH. Okay, the purpose of ROGAM is to prevent sensitization in RH negative mother carrying RH positive baby. Okay. If you are negative and your husband is negative, your baby is guaranteed to be negative. This is not something you have to worry about. You can only get sensitized if you are carrying the positive baby, right? Okay. Another key thing is to know that the ROGAM prevents sensitization. It does not cure or reverse sensitization. If you have already been sensitized, giving you the ROGAM is not going to do anything. Okay. So what do? The ROGAM is given to the mother at 28 weeks of pregnancy, as well as within 72 hours of delivery. Okay. So let me just draw this one more time. You are familiar with this drawing now. That's the mother's blood. This is the baby's blood. Baby is positive. Mother is negative. Okay, so let's go back to our first pregnancy. Okay, first pregnancy. Placenta. I'll give you a moment to catch up. Okay. We are going to give this mother a shot of ROGAM. Okay, so that's the ROGAM. RH. All right. Now let's say that the placenta was damaged during delivery, okay, or even during the second, third trimester, okay? Listen for a second. If the baby cell goes into the mother's bloodstream, it's okay because the mother received the ROGAM. Okay? So the ROGAM will destroy all Rh positive cells entering the mother before her immune system is activated. Okay, and therefore preventing sensitization. Okay, having the ROGAM will mop up all the Rh positive cells that are coming in. They clean it up so quickly that the immune system will not be activated. The mother is not sensitized. Usually people have a good question at this point. Anyone?
Can this rogam move into the baby's blood?
That's the question. That's right. So, isn't this a, like, people were thinking, isn't this a problem? Like, wouldn't the ROGAM like cross the placenta and cause the very thing that we are trying to prevent, right? The answer is no. Okay, because ROGAM is made in the lab, it's man-made, right? It's artificial, right? They make it very big. Okay, they are too big to cross the placenta. Okay, so all the ROGAM will only remain in the mother's blood. Okay, it's not going to go into the baby. That's all. Okay, but in subsequent pregnancy, like the next pregnancy, she would need another dose of ROGAM, right? Because as you will learn next class, antibodies that are injected, they don't stay very long. Okay, they will go away after a while. As opposed to antibody that you make yourself, those stick around for some time. All right, that is everything for sensitization and RH and stuff like that. I think we should take another break, okay? Because I still have a few big things coming to explain to you. Maybe just another 5 minutes or so. Okay, so let's come back at 10 30 34 or something, okay? If you have questions, just leave them in the chat. Okay. Okay, let's keep going. Now that we have understand, what blood types are, and we spent quite a bit of time talking about two of the major blood types, the ABO and the RH. Let's do some practice questions, and actually, you know what? There's one more thing I have to teach you in the PowerPoint. Okay, so that's the RH stuff. That's what it looks like, the ROGAM. Okay. I want to go through this concept with you. For some people, this can be a little bit confusing, but hopefully it's gonna be okay. Oh, the answers are already here. Let me erase them. Can I erase them? I cannot. Okay, don't look at the answers. Okay. Here, let me just cross them out. There we go. So this is called blood typing. We would actually do this in the classroom if we are in an in-person setting, but now you just have to see it virtually. So this is blood sample, okay, and we want to figure out what kind of blood type it is, right? So we have three dishes here, petri dishes. Okay, in the dish it contains the following antibody. The first dish has anti-A antibody. Second one has anti-B antibody. And then the last one is anti-D. Anti-D just means anti-RH, okay? Anti-RH. They mean the same thing. Okay. Now, I want to emphasize these antibodies are already in the dish. These antibodies are not from the blood sample. Okay? They are just antibody that we put in the dish ahead of time. And what you do is you take the blood sample and then you add it to each of the dish. And you want to see if the blood sample reacts with the antibodies in the dish. Okay? I showed you earlier, if antibody reacts with the RBC, you're gonna have agglutination. You're gonna have clumping, right? So the first dish here, there is a reaction, right? Because I see the clumping, there is a reaction. Because the antibody in the dish reacted with the sample, we can say this person has the A antigen. Okay, they reacted with the antibody A, right? There's no reaction with antibody B. That's why the person does not have a B on their red cell. There is a reaction with RH, so that means they have RH, and that's how we know they are positive. Okay, let's try that one more time. This is a second group, right? Second sample. No reaction with A. That means the sample does not contain A. Yes reaction with B, and yes reaction with RH. The sample is B positive. Reaction with A, with B, and RH. This person has everything. AB positive. No reaction with any of the stuff. So no A, no B. No A, no B is called O.
Negative.
Yeah, and negative. That is all. All right. I have a couple of poll questions coming up. I would appreciate it if you can participate. I'll try to keep it under a minute. Anyone else wants to submit their answers? Okay. The correct answer is D. Okay, D. Negative mother carrying positive fetus. We took a look on it, right? So we want to clear out the positive cells in the mother to prevent sensitization. That's why we're going to give it to, give the ROGAM to negative mother. It's dangerous to give ROGAM to positive mothers. Why is that?
It will attack mother cells.
That's right. All the mother cells are Rh positive. You give a shot of ROGAM, it's gonna start causing hemolysis in the mother, right? That's a very dangerous thing to do. Next one. Okay, I'm gonna leave it at that. The correct answer is C. Okay. If the mother is positive, they don't have to worry about sensitization. Right? No sensitization, no hemolytic disease, right? Some of you might be thinking if B is also an answer, but if the father and the mother are both negative, they cannot have a positive baby, right? So genetically, that's not possible, which is why the answer is just C. Okay, this question. We will do this question together, and there are some things that you can remember to make this easier. Okay. So, 4 things to remember. Okay, we already wrote 2 of these down last time, but let's just write them down again. Number 1, all people cannot have AB babies. We explained this already, right? If you're type O, you can only pass on little I. AB babies needs to have an IA and an IB from each parent, right? So that's not possible. Anybody remember the second one? The second phrase or statement? That's always true. No? Oh, that's unfortunate. AB people, that's right, cannot have O babies. Because to have an O baby, you need to contribute a little I, right? Which you wouldn't have if you're AB. So, 2 more. 2 Rh negative people can only have Rh negative babies. If you are negative, your spouse is negative, whole family is going to be negative, 100%. Can anybody give me a similar statement?
2 Rh positive can only have Rh
100%.
positive babies.
That's an interesting one. Okay, let me repeat what he said. He said 2 Rh positive people will have Rh positive babies. Do you guys agree with that?
Yes.
Yeah? No? Okay, because why? Korea, what do you think? Am I saying your name right? I'm so sorry if I'm not. That's right, okay? Two people can be positive, but if they are heterozygous, then they can still have negative babies, right? Okay, so we cannot make that generalization. Okay, the last one is O, two O people, two type O people can only have what kind of babies?
Oh, babies.
O babies. Right. If you're O, then you little I, little I. If your spouse is O, they are little I, little I. Whole family, little I, little I. 100%, huh? So using these facts alone, we should be able to match the babies. Okay? Let's try that. I gotta copy this thing over. Give me a second. Okay, you should not be doing Punnett square for these questions on the test. It will take too much time. All right, so let's see. I like to start with parents where one of them is A, B, or one of them is O. For example, let's look at the first couple. The mother is AB. The mother is AB. So automatically, I know these are not her babies, right? Why? Because AB people cannot have O babies. We have two choices left. Is it AB positive or is it B negative? It can, okay, yeah, exactly. Cannot be J, right? Because they are both negative, and two negative people can only have negative babies. Okay, and if these are all the babies that are available and one of them is ours, we're gonna take home this one. Do you understand that? So baby L is theirs. You just use process of elimination to do these questions. Okay, so baby L is taken. All right, only 3 babies left. So I don't want to use couple 2 or 3 yet because I want to use couples that have O or AB in it. Those are the easier ones. So let's say baby O, sorry, father O. Couple 4, the father is O. Which means J is not their baby, right? J is not their baby. The father is negative, the mother is negative, then they can only have negative. So if there are only 2 babies left, this one is theirs. Baby N. Okay, that one's no. So that's cool. Please let me know if you have questions. Okay, just type it in the chat if you have it. Okay, next. We have 2 more couples. Okay. We can look at couple 3. Couple 3 is B positive, B positive. And there are only 2 babies left to take home. Well, it's not gonna be J. Because if both of them are B, where would they have an A? Like nobody can contribute an A, right? So that means it has to be baby K. They don't have an A. And finally, the only one left would be that one. All right. There are more practice in the you know what? Let's just do one more together. Okay. I think you guys will want that. Hold on. Okay. This is from the study guide. Okay. Using the same logic that I just used, please match the baby. If you want, you can type it in the chat. when you have it, or you can wait for me to take it up. Oh, as in L for the first couple, is that what you mean? Yeah. Maybe have all four of them, if you could, please. Okay, let's take this up. All right, I'm getting a few answers here. I haven't memorized the answer, okay, but we can take it out. The first one is not a good one to start with because they don't have A, B, or O or anything in it. I'm gonna start with the third one here. Third one here looks good. Okay, so the mother is A, B, the father is O, which means I can automatically reject all of these, right? If the mother is A, B, then the baby is not O. If the father is O, then the baby is not AB. So immediately we rejected 3 of them. And there's only 1 to take home. Right? So that's that. So H is gone. Next, why don't we look at this one? O negative, O negative. Both of them are O, so AB is not an option. They are both negative, so they can only make negative. That's why they're gonna be baby L. So baby L is gone. And then over here, number 4, the mother is O, so AB is not their baby. This is I. And then finally is J at the top. Is this okay? Does anyone want to ask anything?
That's good.
Okay. The rest of you okay? Hopefully. Yeah. So you will have some of these matching. You will have one of these matching questions on the test. Okay. Just 2 more questions and we'll be done. Which of the following is a safe transfusion? Okay, not many responses, unfortunately. Maybe a couple more seconds.
From the cheat sheet, it's very clear.
Yes, use the cheat sheet if it helps, okay, for the test. Okay. So, the first one is not safe because A cannot give to B. The B person has anti-A in them, right? Second one is not safe because positive should not be given to negative. Even though we have one free chance, okay, but we are assuming we don't want to sensitize them either. So not okay. AB positive to B positive is not safe because AB cannot give to B. The B person has anti-A in them. A negative to AB negative, that's okay. There is no antibody in AB to reject the A. Negative can be given to negative. And then last one is not okay. Even though A can give to AB, but positive cannot give to negative. This is a difficult lecture, okay? Lots of moving parts, so watch the recordings again if you need to. All right, second last question. Okay, I'm not gonna do the poll. You guys not really participating. It's okay. Just read it and then I'll take it up. If you are doing a Punnett square, then you are doing it wrong. If you remember the 4 statements I wrote for you, this question is gonna take you, 5 seconds. A person is AB positive, marry someone who's O positive. Which of the following is possible blood type? AB people cannot have O. O people cannot have AB. Done. Right? So on your cheat sheet, along with the transfusion, maybe write down the 4 statements as well. I mean, ideally you would memorize them, right? Okay, but if it helps, it helps. If it helps to write it down, then it helps. Last one. What antibodies could an A negative person potentially produce?
B.
As in the answer B or anti-B?
Answer B.
All right. Okay, good. And a person will make anti-B. That's easy to understand. We wrote it in the chart. And if you are negative, you can potentially produce RH as well, right? Because if you're sensitized, then you will make RH. Okay, that's where we're gonna end today. We still have to do the lymphatic system, but that's okay because the lymphatic system tie in nicely with our immune system. Okay, so don't forget to study for the quiz next week. It's on Monday, and for those of you who are taking online for the first time, there is the lockdown browser, which will prevent you from opening other windows and notes on your computer. And so if you want to use the notes during the class, which is okay with me, okay, you just have to print them out, right, and have a physical copy. Otherwise, if it's all digital, you won't be able to access them during the test. That's it. Okay. Have a good day and the rest of
Sir,
your week.
can I talk to you just 1 minute in private?
Sure. Yeah, let me stop the recording so it's not gonna show